Okay, in this video I'm going to show an example of HDB3 scrambling, and this is based on the AMI encoding technique where a 0 yields a 0 voltage and a 1 yields alternating plus and minus V0 voltage. So here's the value V0, say. And in HDB3 scrambling, we use 0 substitution codes. HDB3, we're trying to avoid having long strings of zeros in our data that is encoded into a voltage on the wire. And the reason we don't want long strings of zeros is because we get just a flat line 0 volts when we do so. And that makes clock recovery at the receiver more difficult when your voltage flatlines with lots of zeros. And so clock recovery is when the receiver synchronizes its clock with the incoming signal, and having lots of transitions from 0 to 1 is important for clock recovery. HDB3 takes 4 zeros and substitutes them with either a B00V substitution code or a 000V, where B stands for a normal bipolar transition. That is exactly what is up here, a alternating plus and minus V. And a V stands for a bipolar violation. So it's the same sign of voltage as the previous one. Instead of alternating, we get the same sign. So I'll try to write that out here. Same sign as the previous. Okay, let me copy and show you the example. 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1, and I've got 2, 4, 6, 8, 10, 12, 14 zeros. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then a 1, 1, 0, 1. And the most recent, and we do the B00V if the number of non-zero voltages since the last substitution, now this is a substitution, when we substitute four zeros, when the number of non-zero voltage pulses since the last substitution is even, we do B00V, and if it were odd, we do 000V. Okay? And so we're assuming that the most recent non-zero pulse was positive, and therefore I'm going to go negative on my first 1, then positive, then negative again, and then 2 zeros and a 1, a 0, a 1, and a 1, and now I have 4 zeros, and so I'm going to do a substitution. I got 4 more coming right after that, and 4 more again, so I get 3 substitutions in a row. We're supposed to assume that at the beginning of the first substitution, the number of non-zero pulses since the last was odd. In other words, 000V is my substitution here. I'm going to do B00V here because following this rule that the number of non-zero pulses since the last substitution, well, we have no pulses since the last substitution right here, and that is the number 0, which is even. Here we also have no pulses since the last substitution because the substitutions are right on top of each other, and that means we get another B00V. And now I can encode this. I get 3 zeros. I get a code violation here. You can see it's going the same direction. Normal bipolar transition, meaning I flip the sign. 0, 0, 0. Here's another violation. Bipolar. 0, 0, and yet another violation. Here, 3 violations. And Then I get a 0, 0, a normal bipolar transition, another normal, a 0, and yet another normal bipolar transition. Okay, so there's what the voltage encoding looks like for this string of 1s and 0s given HDB3 encoding. I'll do the next one more rapidly. 2, 4, 6, 8. 8 zeros, a 1, 2, 4, 6, 7 zeros. And then a 1, and then 2, 4, 6, 8 zeros. And then 2 ones. Okay. Again, our first 1 goes negative because the most recent non-zero was positive. 0, 1, and now I've got a 0 substitution code. I've got 2 of them in a row. And the first one is an odd, so it's a 0, 0, 0, V. And then there is an even because a 0 is even. There's 0 transitions since the last, there's 0 non-zero voltages since the last substitution. And then I get 4 again, and here I have an odd number of I have just 1 non-zero pulse since the last substitution, and so it's an odd 0, 0, 0, V. 3 zeros doesn't get a substitution, but 4 zeros again twice does. And again I get an odd substitution because for this one I get an odd one because since the last substitution there's exactly 1 non-zero pulse, and 1 is an odd number. So I do an odd here, 0, 0, 0, V. And finally here I get another even, B, 0, 0, V. And I can then go ahead, sketch this out. I get a violation and a bipolar, 2 zeros, another violation. Now I get a bipolar, 3 zeros and a violation. There's my violations, 3 of them so far. 0, 0, 0, normal bipolar transition, 3 zeros, a violation, bipolar, 2 zeros, and another violation. There's that violation, and then 2 more normal bipolar transitions for the last 2 ones. Okay, this does it for HDB3 scrambling, and I hope this example helps.